next thing I want to talk about is about basically two more concepts I want to cover. And that is endothermic versus exothermic. So endothermic and exothermic. What does exo mean?
Outside.
Outside, right? Pushing it out. All right, what does thermic mean? So what does an exothermic reaction do?
Makes your body give off
Well, yes,
Outside.
but generally it basically releases the heat. Okay, so it releases heat. Endo, meaning what? Inside, thermic, heat. So what is that actually doing?
Takes heat outside.
Takes the heat from the outside and brings it in. So it absorbs that heat. In fact, these types of, the endothermic reaction takes the heat from the outside environment and uses it as a catalyst to fuel the reaction. Okay? Now, I got a simple task for you. First thing I want you to do is I want you to take your hand and put it on the front panel of the desk. Or back panel, wherever you're sitting, but it's basically on the panel.
I want this one.
I want you to take your other hand and grab the leg of the table. I'm telling you the person next to you, the leg of the table. Okay? Which one's colder?
The leg.
Try again. Which one's colder?
I'm sure the leg.
Try again. Which one's
The
colder?
panel.
No.
Both.
The leg.
Both same. The
Why
leg is
not?
colder.
So Mackenzie says neither one of them are cold. Guys, think about things for a minute. Just stop and you have to change your focus for a minute. What does it mean to be room temperature? Yeah, basically, given enough time, all the heat that's within something or all the cold that's within something will eventually reach the room temperature, the ambient temperature. The temperature in this room is set roughly about 70 degrees, which means that front panel is 70 degrees, the leg of the table is 70 degrees, the top of the table is 70 degrees, the air within the room is 70 degrees. The water in the fish tank, because I don't have a heater in there yet, is going to be 70 degrees. Everything in the room, given enough time, will reach that equilibrium point. Because that's the ambient temperature. It can't go below that temperature, it can't go above that temperature. It's gonna, if it's high, it'll decrease down to that room temperature. If it's cold, it'll warm up to the room temperature. Given enough time. So everything in this room, including the chairs, except for the fact you guys are now sitting in them, so they're a little warmer, are at room temperature. But yet you guys, every single one of you told me the leg is definitely colder. Why? So what? So it's metal. What's special about metal? TJ?
It conducts heat faster.
It conducts heat. It's a better conductor of energy. Metals are a much better conductor of energy than wood. So what we're actually taking out of this is we think about transfers of heat, transfers of energy. Guys, this is a perfect example for you to put out. Remember we gave you guys those 5 big ideas for earth science? This is one of those I want you guys to think about. The transfer of energy from highs to lows. Your body is warmer than the surrounding environment, correct? You're at 98.6, or you should be, and everything else is at 70 degrees. When you touch that metal, your body is warmer than the metal. So what the metal wants to do is it's trying to reach that equilibrium, so it's going to pull that heat out of your hand. When it pulls the heat from your hand, things feel cold. This is literally drawing the heat away from your body. When things are hot, what that means is it's hotter than you. So what's happening is your body now is the low temperature, so your body's absorbing the heat from that substance. Does that make sense? So everything in nature goes from highs to lows. Energy, especially in heat, flows from hot bodies to cold bodies. And that's how things move. That's our energy transfer. So we're actually going to do an exothermic and an endothermic reaction. These are things that you guys can do at home. So I'm going to put this on pause here. We'll actually do this. On our endothermic reaction, 8 degrees Celsius, we do 9/5 of 8 plus 32. So that would have been like 13.5 plus 32. So roughly 45 degrees Fahrenheit. So that's pretty cold. Okay, and that's going from 70 degrees. Remember, guys, at room temperature of water is 70 degrees Fahrenheit, and it dropped down to 45 degrees Fahrenheit. Okay, that's a 35-degree drop. That's just something to keep in mind. The last thing I want to talk about today are synthesis versus decomposition. What does it mean to decompose?
Break down.
And to break down. So let's say I take NaCl. Let's suppose I take the NaCl and I put it in water. What does the water do to the salt? It dissolves the salt, so it separates it, and therefore we get Na plus chlorine, so Na plus chlorine negative. This is a decomposition. We're breaking down a substance. Synthesis, on the other hand, that's where we're putting things together. So again, let's suppose I had the NaCl as separated ions, and it's in this water. And let's say the water starts to evaporate, which means we're losing our water body. Guys, the more water you have, the more it can dissolve. So if you lose your water content, the minerals that are held in suspension, or basically that are in solution, start to recrystallize. Take a fish tank. How many of you guys have fish tanks at home? Anyone else ever seen that line all around? What's happening is you have minerals that are dissolved within your water. As that water evaporates, it loses its ability to keep that amount of minerals in dissolution. So what it does, those minerals then recrystallize. And that's how we get a synthesis reaction. So we lose our water, and all of a sudden it'll join together and form sodium chloride. So we have synthesis and we have decomposition. We talked about exothermic, endothermic. We talked a little bit about pH scale today. Okay. So a lot of different labs we did. Sorry the pH thing didn't quite work out. So I'm going to have to work on it for next year. All right, so that ends our lesson.